Can you guys hear me okay at the back? Or do I need a mic?
If you just turn the mic towards you.
Okay, I hope this helps a bit. So I just like gauging the room before I actually start with the talk. So just by a show of hands, how many of you are in first and second year? Any first and second years? Third years? Like undergrad? What? Bachelors, yeah. Everyone is master students here? Oh, damn, okay. Hopefully, how many of you have studied AI before? Okay. How many of you are skeptic about AI? That was too fast. Okay, so I think we should hopefully be able to help everyone out, no matter what your thoughts and opinions are on AI. But a quick brief about myself. I am Jaiditya, you can call me Jay for short. I am a developer advocate at JetBrains. Basically, what that means is I do workshops like these, I do talks at conferences to help educate people about our products, to gain feedback about our products. You can compare it to developer relations, which is one way, but advocacy is something two-way. So any feedback you give to me, whether it's good or bad, I take it to the product team and tell them to fix things, because that's only how you can make good products for users. And a lot of companies operate this way. Microsoft has these developer advocates, Google has these developer advocates, and that's basically what I do. So any feedback about anything, you can come and give it to me later on. So what can you gain in the next 2 hours? An internship, I will obviously talk about internships. I guess people like internships, or for master students, even jobs full-time afterwards. We are hiring at the moment. The internship cycle started, I think, around 27th of February. It will end around the end of April, and it is for this summer. So we are still hiring for this summer. Then I know in Switzerland, a lot of you guys like doing part-time work, so you can do all our internships part-time as well, instead of doing it full-time. We will learn a bit about AI and LLMs. I'll start from the basics with some maybe fun facts, and then move on to some things a bit more complicated about setting up your own local LLM, or about RAG, etc. You'll see what all those mean later on. We'll try and become a better prompt engineer. So I won't just be teaching you some prompt engineering tips. I will be letting you try prompt engineering on your own. That is one of the challenges today. And like for that challenge, sadly, we will just have socks. But I think the top 3 people within those challenge can like get socks. We will be testing out how you can code in the dark. It's something we like to do at JetBrains, where you don't see your code, or you don't see the output of your code, and you just use prompt engineering to keep building stuff. And then we test out who's done the best job of doing it. We also have some fun challenges, like I mentioned. We'll do a quiz at the end. The winner for the quiz wins this. It's a Cody plushie. This is the Kotlin mascot. It's pretty nice. I kind of love this. I still don't have one. So yeah. Okay. Yeah, the prizes are done. So I like starting off with this. Were any of you at LauzHack? Were you at my workshop? No. Okay, then you guys can answer. When was the first JetBrains IDE created? When do you think IDEs came around? Anyone? You get a sock, by the way, for the right answer.
2016.
No. Too far ahead. Go on. Earlier? 90s? No. Bit later. Anyone? Okay, they came out around 2000. So the first IDE was created was IntelliJ, which came out around 2000. When do you think PyCharm was created? This was a second IDE. Yeah, who is that? Okay, I will give you a socks later. So I wanted to throw these, but I don't think I can without hitting this guy. So I'm not going to take the risk. So yeah, PyCharm was released in 2010. And this was our third IDE after Rider. And it looked sort of like this. So it's progressed a lot since then. If you've used PyCharm recently, you know that. This was the history of our products, as you can see. And so moving on to the fact about offices, we don't have an office in Switzerland. So if you do take an internship or a job with us, you will be in one of these countries. Now you can choose to be in London as well, which is the newest thing, which is still not on here and updated on our site, but it does exist because I work out of London. So these are all our offices. You can also choose to work remotely, but the offices are really nice. We also have a slide in one, but they couldn't let me put pictures of the slide. So sadly that. Some other things about the company, we built Kotlin. It's a programming language. It can be used for all of these things. It's the official language for Android app development by Google. And this is some facts about Kotlin. These will be included in my presentation, which I'll send later. So it's just mainly for that. A cool thing we have, how many of you are applying for jobs or internships? Okay, so especially for you guys, if you're prepping for jobs/interviews, this helps out a lot. It's sort of like those, it's like Lead Code, but it's crafted more for the interview itself. So it'll have similar problems to technical interviews and you can practice on here as well. It's completely free for students. And for people like Eric who like doing courses, you can also use it to create courses. If you are also a PhD candidate and you're teaching some lectures, you can actually use JetBrains Academy to create courses yourself, which your tutees can do within the IDE. So it's a good tool to have for everyone. Okay, so for the internships, I'll quickly just be showing you how the internships look like at JetBrains before we jump into the talk. So currently we are at this cycle called 3.0. So when you go to the internships page and you log in, you'll be able to see something like this. So the good bit is we don't have a software engineering role that's open. We give you the projects. So it's sort of like picking a project you do at university where you choose the topic and then you apply for it. Because we don't think it's worth your time if we get you in as a software engineer, you hate Python, you want nothing to do with it, and then you're assigned to a desk that does only Python. It's both painful for you, the company, because you don't want to come back after that. So we let you pick your own projects, apply to them. You're interviewed by the manager who will be your manager during the project, which is a very nice system so that you guys can get along as well. The process is simple. After you say, pick a project that you like, maybe this, you are required to do some tasks. So these are the samples of the tasks that can be there. They take up to about 2 to 3 hours to complete, at maybe up to 5 hours for some tasks if the role is more extreme. But after that, you just have one interview and then you're in. That's the process. It's as simple as that. There is nothing more. So you can apply up to 5 of these projects when you do apply for internships. And that's about it. So any questions, you guys can come and chat with me later. So we will, okay, so now moving on to the talk itself. We will start with some basics. I'm guessing most of you know what LLMs are considering your backgrounds, but we can start at the core of it, which is neural networks. We start from the definition. It's on the screen. How many of you know what neural networks are? How many of you have built a neural network? Okay, quite good. So we skip that. How many of you have seen this before? How many of you know of this analogy? No one? So this is, okay, what is it? It's called a stochastic parrot. So a stochastic parrot is, what does stochastic mean? It means that it's random, so it's giving you random results. So you have a parrot at home. It's been listening to whatever you speak with your family, etc. So the next time you want something for breakfast and you're like, oh, it's Monday, I feel like having this. The parrot might know what the answer is because the parrot's been at your house for a year and it's been listening to all your conversations. So it is very weird comparing an LLM to a parrot, but that's basically what it is. It's been trained with some data and it's good at completing a sequence of text that is happening. And that is what the stochastic parrot is. It also gets trained by conversations. So this is a language model. This is how language models work. Now, if this parrot could hear information from everywhere around the city, and it was getting information from your neighbors about maybe what the doctor is doing, etc., that would be a large language model because it's trained on a bulk of information that might even let the parrot be able to give you medicine. So, I mean, don't take medicine from a parrot, but you can, that's what it comes out to. So that's how LLMs work. And this is the stochastic parrot analogy. I find it pretty interesting because that's how they actually started thinking about them. So an LLM is basically assigning a probability to a word that can come after a set of words. That's literally what it's doing. These probabilities basically demonstrate how what a hypothetical AI assistant could say. And okay, anyone? How many years do you think it would take for you to read everything GPT-3 went through? Again, there's a price for every question, guys.
100.
A lot more. It's in the thousands. Bit more. I'll give it to the 2000 guy because he said it first, but it's around 2500 years. So you would take 2500 years to read all of that information, continue, like even if you sat and read data 24/7. And that's what it has done. Now, that is not enough though. So there is a second layer to it, which is you assign parameters and weights, because a word can have multiple meanings, which we know. And the AI sadly doesn't know that, because it is just a vector being mapped to a certain set of words. So each word has some vector which is assigned, which is just random numbers. And that is why you need parameters and you need weights. And they are defined. So you keep going through a process of assigning some weights and parameters and then reiterating with the first training model itself. And this is called pre-training altogether. So that when you have something, say, like the word bat, whether it's the mammal or whether it's the like cricket bat, that has to be known. And this is what it helps it do. So these weights and parameters make it read the word ahead of it, behind it, and sort of create an analogy related to it. But this is not enough, because even despite that, there can sometimes be bad outputs coming out of your LLM. So there is a next layer, which is reinforced human learning. And how it works is the outputs are actually evaluated by humans, and then they are sent over into a reward model, which updates the LLM. And OpenAI actually did this when they came out with GPT. And they kept doing this with a bunch of people who just had to sit and look at its responses and like classify it as maybe censored. They had to censor some stuff initially, and that's how the model was actually trained, with actually using humans develop it. It wasn't done all unsupervised. There's another thing, which, because sometimes there will be cases where the answers might be wrong, or it might just be assuming some random answers. So this is another thing you could do to make your LLMs better, which is retrieval augmented generation. RAG, basically, where you have a date. So say you wanted to get information about which planet has the most moons. Now, this information keeps getting updated again and again and again, because believe it or not, we are still finding more moons. So it used to be Jupiter. I think now it's Saturn, because we found, I think, 4 more moons on Saturn, near Saturn. So this information keeps changing. And the LLM, because it's trained a while back, it can't have the latest information. So sometimes it needs to check that information with some data, with some factual data, so that it doesn't give you the wrong answers. And that's what retrieval augmented generation does. It checks your query with a data store as well, which has some of the information based on LLM generated smart searches. And that's how an enriched answer is reached to. This is also something you can build out on your own with pre-trained LLM models. So say you're using Llama or a pre-trained model, you can just build out a rack system around it. And it's been like a lot of hackathon projects where people have just connected the LLM to a data store to be able to do some specific task. And most of agentic AI works this way. And the good bit of this is that it sometimes just says that it does not have the information, which is nice, instead of it just creating information. So yeah, that's one more bit. The last thing of importance with the use of LLM is, what are these? Anyone knows? There is no price for that, by the way. This is too easy. So this is like a GPU. And why are GPUs used? Anyone?
Because they can do matrix multiplication quite fast, and we use matrix multiplications.
Yeah. So it basically, it does exactly that, and it lets you run things in parallel. And that is why GPUs are used for both training and running your models. And yeah, with that, we can move on to the next bit, which is, how can you run LLMs locally? So how many of you have a paid subscription for either GPT or something else like that? How many of you find it a bit too expensive? That's why you've not taken it. Okay. Maybe it's none of that. Maybe you just like want to have something of your own. So I'm hopeful that because all of you've learned AI, you've hopefully seen this website before. If you haven't, it's a bit concerning. But on Hugging Face, you can find models for different users. I went with DeepSeek because it's the latest and I wanted to get something downloaded. And I used Llama Studio. And you can just use either this or many other applications like this, like Olama or something something else to run these open source models on your machine. Now, this will probably be slow, depending on which machine you're using, but you can easily connect it to your own cloud GPU or something of that sort as well, which are cheaper than actually buying physical hardware always. And it's also cheaper than buying AI tokens. And it makes your life a bit simpler, and you can use custom models instead of the one that are being given to you. You can then, after you have a model, you can go to its API documentation and maybe custom train it for RAG with using RAG or something of that sort to make it work for particular use cases that you want to build. And it's very easy, and the access is with everyone. Even for OpenAI's model, if you don't want to do something that complicated, OpenAI like gives you the access keys. And though these now come at a cost, there is API documentation, which is very well written. And you can easily go and set up anything on that front. So the pricing's there, but I'm just going to show you. So these models can be fine-tuned when I say fine-tuning, and you can prepare custom data sets, which have to be formatted the same way to train them. You can also check what the prompt generation schemas are and use the APIs to. So when you're using a model locally, you have to send a command to it, which will include whatever text maybe you entered and the pre-generated prompt and guidelines. So these guidelines can be custom set, not just on these, but also on GitHub Copilot or something of that sort that you use, which I'll show pretty quickly once we're done with the slides. And when you're using an AI assistant or whenever you're using even AI to code, it's good to have your prompt given, like a prompt library defined or guidelines defined, which the AI works off of. So something funny like I like to say is you can just ask your AI to reply back in rhyme, and every time you ask it something, it's going to do that. And there is nothing lost there. And with coding, you can have stuff like, okay, not more than 20 characters in one line or 50 characters in one line of code, not more than 3 new functions created, or do everything within the same function, etc. You can predefine it with any requirements that you have, which is pretty nice. So that's a bit about running LLMs locally. There is also stuff you need to be careful about, which is, so how many of you have heard of GGUF versus GGML? Like, how do you know, how many of you know what that is? So GGML is these are the data formats for these models. GGUF basically lets you keep it at a lower volume, lower size, and lets you run them locally easily. So when you download the GGUF file version, it might help you basically fine tune it very easily, even run it easily. What does happen is when you do something like this, the model does lose a bit of accuracy, but the better the models become, the lesser accuracy is just lost. So with the newer models, you might lose less accuracy, even in using the GGUF and the lower sized files. So you're not going to be running 5 GB of like using up 5 or 8 GB of RAM anymore. You can do it with say 1.25 GB of RAM because you can tone it down to 25%. Also, something important which I like to show is context length with Llama C++. So this is something important to keep in mind when you're coding and when you're writing, when you're training your own stuff. I can't find the website, but you should take advantage. I will be sending all these links and articles later on. but you should be using context length to help your LM performance, to help handle tasks. It is basically giving it some particular set of characters, or like giving it enough context, enough information to help it be able to do its search. But we'll come back to this when we go with prompt engineering. Yeah, so I think that's about it for running LLMs locally. Next is training your own model. So I would just like say some things that you need to keep in mind, which is there is 5 steps of training your own model. Say you want to identify images. The 5 steps would be: identify your images, build your layout hierarchy, how these images are going to be placed on a page when you're giving it an image, what component should it search for. Then you apply sort of styles to the image you want to have generated. So you tell it to maybe have no background and have a white background and just focus on the object, or tell it to, and then you make it turn it to basic code. And then you customize this code with, say, margins or padding or something like that. So that's how the training of your own model bit will work, where you will train it for each of these specific tasks, and each of these will be specialized models of their own. For each of this, the best thing to have is a lot of data. So when you're custom training or fine-tuning a model, when you've taken an open source LLM, have a lot of your own data, or find like data stores online. Otherwise, there won't be any use. Also remember to format the data properly, because each of these open source LLMs, even the public ones, all of them have different kinds of data formats, even when you're using APIs. So what do you think are the biggest challenges with LLMs? Just what do you guys think on your own currently?
Them to not hallucinate.
Yeah, that is one big challenge. So I'm guessing all of you know what hallucinations are, but a good example is if you ask most AI models the spelling of strawberry, it's going to have 2 R's. So that's like a big challenge that is there. And it's a text hallucination example. I'm guessing most of you have seen image hallucination example where it just puts a cat's face on a dog's body or something like that. But yeah, that is one challenge. Anything else? The second thing is information keeps going out of date, which is where RAG comes in and helps you out, or you can just update the RAG data store.
User give some feedback.
Yeah.
Again, teach that the user can give some feedback for where we can check.
Yes. Exactly. Yeah. So misinformation is also a big problem, and that's where also RAG helps. So if you've not studied the RAG structure before, why I keep emphasizing on it so much is that for students like you who already know what LLMs are, RAG might be an interesting concept to study and look up, because it's what's forming the basis of agentic AI, which I'll just talk about in some time. Okay. So the first bit. Why prompt engineering is becoming an important skill. By an important skill, I mean people are actually hiring for it. Not just us. Many companies are now hiring prompt engineers, people who know what they're doing, because even if you're building a wrapper, the most important part of companies building wrappers like Perplexity, like anyone else doing it, is prompt engineers. If they don't have good people in the background, both helping fine-tuning and both helping whatever the user prompts to be shaped better, this won't work and the results will be pretty mediocre. So it's forming an important part of the AI infrastructural world. So this was one of the first original programs, which was somewhat a gimmick. So this looks like it's processing natural language, but it's not doing that. It was a psychology experiment to sort of create an illusion that used pattern matching and some computing tricks to help you have a conversation with someone who seemed like a therapist. Now, why this got brought up very later on was that the scientist who created this actually discovered that his assistant or receptionist got too addicted with talking to the AI bot, and they just sort of got lost in a loop. And that was a thing that happened. But this is what initially sparked interest in natural language processing. This was the first thing back when no one was doing it. This psychotherapist decided to create Eliza. And the whole part was that Eliza just keeps asking you questions, and every response you give, it'll pacify you and ask you another question. So it felt like someone who's trying to calm you down and ask you questions. And this did help people back in the day. And later on, multiple years later, this came around. So what does GPT stand for? So many of you study AI, but do any of you know what the actual full form of GPT is? How many of you have used GPT, like ChatGPT? How many of you know what GPT stands for? Yes, that is exactly it. It stands for Generative Pre-trained Transformer. And this came around 40 years later from 1966. It came around 2010 when deep learning and this came around 2018, actually. 2010 was when deep learning and neural networks came into play. And that's when people started talking and researching into them. And OpenAI emerged with GPT in 2018. And it was trained on books, articles, and chunks of the internet, like Wikipedia and just some blog sources. In 2019, GPT-2 came around. Then you had BERT, you had Llama, you now have Claude, which is, I think, the top of the line. You have Grok, which I don't know if it's good or not, but yeah, you have many more things come around since then. And 2025 was when most stuff started coming around. Now with prompt engineering, the basics, so you can have prompts in multiple forms. You can have text, you can have code, you can have images, you can have video, you can have audio. Once you have this, you have to have 5 parts in a prompt you are giving. It's a task, a context, a references, then you evaluate, and then you iterate. So these are the 5 steps of prompt engineering. And I would say if you want to work in AI and if you want to work not on the training, but on the engineering side, and you will be doing a lot of prompt engineering as a part of your work. And though it seems like prompt engineering is just, okay, can you talk to AI properly? It's not that. It is the structure you give a user when they're using your AI tools, so that the user just has to enter one line and you have information surrounding it so that the query works properly. And the task bit is you add a persona. So you tell based on what the task is. If the task is to do some data science work, you tell the AI bot to act like a data science expert. And maybe you tell it to, based on the task, based on what the user's task is, you tell it that you want a bulleted list or you want a table. The next bit is you give it as much context as you want. So if you built a tool that, I don't know, let's go back to space, does space work? You give it NASA documents to read. You give it multiple space fact books to read. Like you feed it the encyclopedia. So give it as much context as possible before it has to answer. And references. And then you can evaluate. So evaluation is basically when you're testing it, when it gives you an answer, are you actually happy with the answer or not? If you're not, you go to the 5th step, which is iteration. And these are the 4 things you keep doing till your AI works properly. You revisit the prompting framework. You put your prompts into shorter sentences. So you remember the parrot I mentioned, the stochastic parrot. Now, if you were talking in big sentences at home and you just like kept word vomiting and you didn't make any sense, the stochastic parrot would have no clue what you just said and would get information wrong. The fact that you use shorter sentences when you're talking to people and you talk in a conversational way, that helps. It might seem weird and cringe talking to your AI like a person, but it does help the AI understand what your actual prompts are. Then maybe use some other terminology. If it doesn't understand what a marketing plan is, tell it to tell a story. Use some analogous words to what your actual task is. Also, lastly, add constraints. If you're asking it for a playlist, don't just ask for a playlist. Maybe tell it that it needs to be in pop. It needs to be music between 2018 and 2025. Otherwise, it's just going to give you random songs from some website sourcing that it could find, which might have nothing to do with you. You might get random K-pop music, or you might get random, I don't know, Bollywood music that you don't have any clue what it is, and it's not what you wanted. So yeah, be careful about constraints. So yeah, now it's time for the challenge. And maybe for the challenge, could you guys take out your laptops? Do most of you have a AI assistant installed into your IDs? It could be any, it doesn't have to be IntelliJ or PyCharm. It could be any ID, like, or you could just use Cursor directly if you want to, if that's what suits you. So do most of you have that? Anyone who doesn't have an AI assistant, raise your hand. Okay, quite a few. You can get GitHub Copilot on whichever ID you are using, which if you're using JetBrains IDs, you can just go get the GitHub Copilot plugin. It's free for students. So one of the people who doesn't have it, who is willing to try this out in front of everyone on my computer? Who wants to be the guinea pig? I need one of you to step up. So you'll just be doing, so you can read the challenge description already. You will be doing this challenge on my machine using JetBrains' AI plugin. You wanna come down? Come on ahead. So basically the person who does the best job with this doesn't win this, but they still get a sock. So the top three things get a sock. And also the top three of you will also get access to JetBrains' AI plugin. So I will give you free access for a year to use our AI assistant. Okay, I'm just gonna maybe open up IntelliJ for you.
Don't have PyCharm.
Do you want to build a product in PyCharm?
Okay, I haven't done code in Java for a while.
No, JavaScript.
Uh,
You have to build Instagram. So I thought people will use JavaScript.
no, I'm not good with JavaScript.
Okay, someone who's confident with JavaScript and building the UI, maybe. You know what? You're not good with JavaScript. That's a good sample. You can just explain the tasks and let's see if it can do the work for you. Okay, so I'm gonna just create. So you can open like a template project for. Okay, I'm gonna put this on here. Okay, quickly just explaining the challenge, guys. You have to create Instagram. I'm gonna set a timer for 3 minutes. Until I start the timer, please don't start coding anything. You can set up a basic React or whatever kind of project you want to set up, whichever thing you are comfortable with. So you can just have the sample project with Hello World open, and then everything else has to be done with your AI assistant. You're not allowed to look at the output until I say, okay, the timer stopped. You have 30 seconds to look at the output. You can do npm run dev or whatever you're doing, check the output and go to